Today we are going to go over electronegativity and ionization energy again to make sure that we are ready for our tests. So I'm going to do a few videos on what electronegativity is and how we can compare two elements using the periodic table, and then I'll do the same thing for ionization energy. And so as we saw Friday, electronegativity is the ability to attract electrons, and what that means is how likely it's going to gain electrons. And so as we discussed on Friday, elements that have more than 4 electrons in their valence shell are going to gain, and elements that have less than 4 are going to lose. So if we draw a line on the periodic table, if it's to the right, it's going to gain electrons because it wants to get to that 8. And if it's on the left of that line, it's going to lose. So 3, 2, 1 are all going to lose because they have 8 on their inner shell. And so when we talk about attracting electrons, these guys over here, the 5, the 6, the 7, and 8, they are going to have a higher electronegativity because they want to gain electrons to get to that 8. It's going to be easier for them to get those electrons and attract them because they want them. And to the left side, with our 3, 2, 1, it's going to have a lower electronegativity because it wants to lose electrons. So if it doesn't want electrons, it is not going to attract them at all. And when we look at the periodic table, there is a trend. So as we go up the periodic table from the bottom, as we go up, it increases, and as we go to the right, electronegativity increases. And that is because as we go to the right, we are adding more electrons, making it closer to 8. And so when you add more electrons, it wants to attract them more to get to that 8. When we are looking at elements to compare them, we have to look at where they are in the periodic table. So if we're comparing, we are going to compare, let's say, fluorine and francium. Well, fluorine has 7 valence electrons because it's in that 7 valence column. So everything in this column has 7 valence electrons. So it's really, really close to 8. Francium has 1 valence electron, and it also has lots of electrons because it has 7 rings around its nucleus full of electrons. And so when we compare them to, fluorine is going to have the higher electronegativity, and it actually has the highest electronegativity of all elements. And francium has the lowest electronegativity because it has so many electrons. It doesn't really care if it loses them or not. It doesn't really need more. Fluorine wants to get to that 8. It's so close to that 8 valence electrons, so it's going to have the highest electronegativity. If we're comparing two different elements, let's see. Let's do magnesium and cesium. Those two right there. Cesium is below. It's lower on the periodic table, and it's more to the left. Magnesium is higher, and it's more to the right. And electronegativity increases as we go up and to the right. So that means, following the trend, that it increases going up and to the right, magnesium will have the higher electronegativity. So it wants to attract electrons more than cesium. Now let's look at magnesium and phosphorus. So we know where magnesium is because we just did it. Now we're also looking at phosphorus. Magnesium is more to the left. It only has 2 valence electrons. Phosphorus is more to the right and it has 5. So magnesium wants to lose electrons. Phosphorus wants to gain them. And based on that, we can say that phosphorus has the higher electronegativity because it wants to gain electrons more, because it has 5 valence electrons. Magnesium only has 2, so it doesn't want them as much. So when you're comparing two elements, you have to look at where they are and how electronegativity changes as you move across the periodic table. So as we go up, it increases, and as we go to the right, it increases.